So now there's all that good stuff we saw before in here. Let me just make this window a little bigger and turn that off. Again, my symbol table is really just a hash table, so that's that part of there. I can create a symbol table now based on another symbol table. That's very useful because now I can chain them together by passing in the parents. Now I can take a symbol table and say, give me a new symbol table based on the old one. And you can see that I ought to maybe have commented some of the code in here, but hey ho. It was hard to write, it should be hard to read as well, right? That I have a parent. Let's take a look at how put is implemented. And apart from a little bit of error handling there, it's not too complicated. So it says entries is my hash table. Go and look up whatever name, and if I get something back that's not null, then go and complain and say the symbol is already defined in this scope, right? So if I have int a, comma int, or int a, semicolon int a, then that second a will cause this to blow up. If not, then just put that name into the symbol table with whatever entry here, and that's going to be the declaration, either local decal, prime decal, or field decal, or whatever decal. Okay. How do we look things up? That's easy. We use the get method on the hash table, and if I get something that is not null, then return it. If I end up with this if statement, it's because I got something that was, well, I didn't get anything, I got a null. That means that whatever I was looking for was not in my symbol table, but if I have a parent, then go look in that. If I don't have a parent, then return null, I didn't find it. But if I do have a parent, then just call get in the parent symbol table, and like I move my way up in the hierarchy of symbol tables. So if it's found somewhere in that chain, that will find it. There's my toString, just to print things out, and here are, see, it's even commented on whatnot. There's new scope and close scope. What does new scope do? Well, it creates a new symbol table based on itself. So that just takes itself, passes in as the parent to a new symbol table, and returns it. And the close scope just returns the parent. So that just gets rid of itself. So that's fairly easy to work with. Now what we need to do though is we need to find out where in the code do we open the scopes and where do we close them. And also we have to figure out which parse-tree nodes should I re-implement in my visit with respect to not only opening and closing the scopes, but also the use of names for classes, fields, and methods. So we'll have a name checker visitor, which will deal with the declaration of locals and parameters, opening and closing scopes, and use of all names. So let's see. So I have three things. I have the stuff that declares something, the nodes that deal with scope, and the nodes that deal with use. So I need to find, I believe it's 13 in total, if I'm not mistaken, plus minus 1. Different parse-tree nodes, and sort them into these groups. So we'll do the declarations first. Which parse-tree nodes declare something that I haven't already dealt with respect to names? I have my field decal over here, I have my local decal, I have my constructor decal, and my static initializer decal, sorry, static init, which should have been static init decal, but hey ho, and class decal. What other decals are there?
Isn't there an interface decal?
No, that's a class decal too. There ought to be an interface decal. It would have been nice if there were an interface decal. declared.
Class body decal?
No, that's a super class for all those four over there, just so we can make sequences of them. What were we just talking about?
What can be declared?
Huh?
What can be declared?
No, as in, the answer to the question was, what were we just talking about? Not, I'm suffering from Alzheimer's, I can't remember what I said a minute ago. Yet.
Var decals. Is what you're trying to say.
Again, it's a superclass for the two things we're looking for. Yes, and? Yes, but may I? I'm not saying you're not paying attention, but, so.
I thought, when you said the ones we aren't declared, I thought those were part of the ones you already mentioned.
No, because the ones we've already declared, yeah, right, you see. So param decal and you said local decal. Okay, what should I do if I were to hint at the implementation of visit param decal in the name checker.java file? So what should I do in there? Well, I need to insert myself into the current scope. And the same goes for local decal. I'll leave it to the method decal to open this scope. I'll leave it to the block to open that scope. Again, that was the block that opened that scope. So whenever I hit a decal, param decal or local decal, I can just insert myself into the appropriate scope. So these are both just insert into current scope and be done with it. So those are one-liners. That's good. I think we might need a little bit more space here. So I'll move the use out of here. Now what opens and closes the scope? It's created in such a way that the node that opens the scope also closes it, right? Else it will be a mess. But which parse tree nodes would have anything to do with opening and closing scopes? Well, the method decal for sure. And the method decal needs to do, so it opens scope for parameters, and then it visits children, and then it closes the scope, right? So open the scope, go visit the children. Some of those children might be param decals. What do param decals do? They insert themselves into the current table, so they will get inserted into that table. And then you go and visit some of the other children, which might be the body. They might open scopes, they might insert themselves into tables, and so on and so forth. And by the time I'm done dealing with the children, I've dealt with the parameters, and I've dealt with the body, so I can close down the scope that represented the body, the parameters of the method. I will suggest I'd suggest a constructor decal as well, right? Because a constructor declaration is very much like a method declaration. It has parameters in the body.
So you did the class decal or the class and body?
Class body decal is
okay,
abstract, so we can't do that one.
Sorry, class decal.
But what should I do for the constructor decal? I'll let you go if any of you guess it right. Then you can have Monday off too.
Really? How long do we have?
Oh, all of 10 seconds. Maybe I can't sit here all day. Well, an obvious reply to that question would be the exact same thing as the method decal, right? I open a scope for the parameters. I visit the parameters. They will insert themselves into the current scope. I visit the body, and the body will do whatever the body needs to do. And then when I'm done, I close the scope down. Sounds reasonable? Sure. Except for one thing. The problem, if you pull out your grammar, I suppose you can do that here. Right? If we pull up the grammar, remember while this warms up that I needed a symbol table for the parameters and I need a separate symbol table for the body because I want to be able to hide parameters, right? And if they shared the same symbol table, I couldn't redeclare variables with the same name. So it's important that a body also opens the scope, because if it didn't, then local variables declared at the top scope of a method will go into the same table as the parameters, and that would be a mess. So we need a block to open the scope as well. So look at this one here. So here's a method declaration. Yada yada yada, method body. What's the method body? Well, it's a block. So by visiting the method body in visit method decal, we get a new scope created simply from the fact that we did a block. When we see what a block does, a block would open a scope, visit its children, close the scope. So that'll work fine. Now, if the body of a constructor decal were a block as well, then the answer would be it will do exactly. We should do exactly the same thing as a method decal. Let's go find the constructor. Oops. So look at this here. That constructor body there. Well, I suppose what we actually should do is we should probably just look at no, just the constructor decal. Because well, actually, let me show you method decal first, because you can see that here's there's the body and it's a block. So I know that that'll open a scope, and I won't get the possibility of clashes between parameters and locals called the same. So now let's look at constructor decal.
It's got a sequence of bodies.
It does, doesn't it? And that's not so good, because this thing here, sequence of statement as a body. So that's not a block. So that means when I go and visit this sequence, and what does the sequence do when you visit it? It just goes and visits its children. So what I have here is I have a sequence of statements constituting the body, maybe preceded by a invocation. But I certainly don't have a block that will get visited and open a scope. That's a problem. So I have to be a little sneaky when I implement visit constructor decal, but it's no more complicated than this. Open a scope. Visit the parameters. Now open another scope. Visit the body. Actually, what you do is you visit the C invocation and the body, and then two times close scope, right? And this actually took years before we found out that this was a problem, because nobody ever tried to have two parameter and local named the same. Okay. Anything else that opens scope? Well, yeah, I already told you block. And that one is easy. Open, visit, close. So visit children. Is there anything else that opens the scope in Espresso or Java? Well, it's Espresso. I'm concerned, but it does do it in Java as well. It was a funny little peculiarity. What if I write something like this? Actually, what happens if I write something like this?
You can't, it won't let you.
How much money you got in your wallet?
No.
I've got Canadian money. I'm willing to bet things.
I got none.
Sure, it will let you. You're saying you can't do that because you already declared I?
Yeah, and it's being used inside
Oh,
that
but the
scope.
I, oh
No, because what's the
Oh.
what does
Well,
the
yeah.
parse tree node for look like? It has something, 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 and a statement, right? And that has something, 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 and a statement, which is a block, and a block opens a new scope. So by the time you get to that I here, you have a fresh scope associated with the block in which this can live, and it would overshadow or hide that one. Yes.
And then you could never access the one that was declared.
Right.
Sure you can. You can say things like this.
Oh, okay. And since
I mean, which is completely useless, right?
But how would you update the,
That happens here.
It will get a there, but it will never be used.
so
No,
you,
you
can't-
have
you can't
you have
manipulate it inside.
you have a problem because I don't know what happens if you actually. That's a good question, and I never thought about what happens if I write something like this.
I plus I.
And then I yank this out here, right, and I just say I equals 0. And let me just say here, I less than 10. Of course, by the time I get to here, no I is valid, right?
Mm-hmm.
Because what's the scope for this I here?
It's the for loop.
The for loop
yeah,
and,
yeah.
and its statement,
Yeah.
of course. And what's the scope for this guy?
Everything after.
The rest of that block there, right?
So it won't run forever.
Well, so this update here, which I am I talking about there?
The one in the for loop.
The one in the for loop. So I'm talking about this guy.
Because the other one loses scope.
Right, but how does the code you generate for this look?
Create block, do it, throw out block, for loop.
I'm going to have to try this because I'm not sure my code generator does this right. You see what my problem is? If when I generate code here, I think if that I is that I because this stuff here goes all the way down to the bottom. When I implement this, then bad things could happen. I don't know if that actually.
Isn't it just the same thing as putting I++?
Yes.
Yeah,
But my problem is if this code here gets physically moved, this for loop like this is the same as while I is less than 10, you do the body. I something like this, right? Hold on a second. And then you do the dot, dot, dot. And then you take that thing and you say I equals I plus 1. That's always how we've written these, right? When we've done rewritings. I don't think that's right.
no, it's not, it won't be the same.
That is not the same. The correct way to rewrite this thing would be as follows. Int I equals 0. While I is less than 10, curly bracket,
And then another while.
curly bracket, I equals I plus 1. And then what needs to go here should be the exact same body. What does that body look like? It looks like this, curly bracket, int I equals 0, dot, 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 curly bracket end. Because now, once I hit that curly bracket, that I is gone, right? However, well, I mean that's perfectly fine, right? Because this I gets initialized every time I go around here anyway. So that actually that rewriting there is actually correct. This one is not because that I will be that I now. So I never thought of that. That's because every time I've ever done this rewriting, I've just taken this code right here and plugged in at the bottom, not thinking about scope at all. Huh? Interesting. So anyways, we need to put a for loop here. So what should the for loop do? Well, it should open the scope, visit, children, and close scope. Anything else that opens or closes scopes?
What happened to the class deco?
The class deco was dealt with over here.
Oh, yeah, never mind. Automatically opens.
So now I have 1, 2, 3, 4, 5, 6, which means you just have to find another 7 that actually use names.
If, switch, and stuff like that.
Easy now, easy now. So before you get carried away, I'm just going to check to see if we got it right. Actually, grab. So let's see, we have block, we have local decal, param decal.
Because of while. Well,
Okay, so let's see. Obvious one to put here that uses a name.
name expression.
Name expression. That one is nasty. But I'll put it down. Up. You don't mind if I put it further up here, right? So I'm just gonna. Can we leave that one for a little while because that one is a little nasty. Another obvious one. Funny enough, people always forget name expression.
I thought that was the obvious one you were asking for.
Well, I want.
When you say use name.
I want 6 more.
Oh, okay.
What else uses a name?
Invocations.
Invocation. What should I do in an invocation? So what should I fill in green here? What job do I need to do? Well, I need to make sure that the method is declared. So go into the method table, use the name in the invocation to look up to see if there's a method that fits. Now that's of course not the whole story because we don't know that the parameter is actually going to fit in, but we can't do anything about that until we get to type checking. So all we are concerned with right now is there anything by the right name? And by the way, if the target is too complicated, so if it says a.x.f of 7.g of 45, then I can't check that g is a valid invocation because that target is way too complicated. That also requires type checking. So this only works if the target is simple. In other words, something where I can look at it and determine which class holds the method table in which I should expect this method to live. Now the obvious one, of course, is where the target is not there. If there's no target, what class should I look for the method in? Well, then it has to be the current class, the class that I'm in, all right? What other targets are simple enough for me to maybe be able to do something useful? Remember, an invocation looks like something dot some function dot 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 a method. So that is the target. What can appear there that's simple enough for me to actually determine the right class at this point in time? How about this?
Class deck.
Yeah. So, no, it would never be a class deck, it would be a class type if it was something. But definitely, if it's this, what class should I look in then? Same one, right? If it's a super, yeah, the parent class, the super class, the one you extend. Anything else? Well, if it were the name of a class, we probably could figure it out too, but then we're essentially getting to a point now where it gets complicated. So we could do all of these. I think if you just do the first one, if there's no target, we'll figure it out. If it's a this, that's fine too. The super one, we don't really, I don't care if you deal with that one right now. But these two here should do the trick. Okay, what else uses a name? I still need another 4 things. Well, actually, I need 1, 2.
Let's go with,
I think
switch
I only
statement.
need 2 more. So, huh?
Have we already done switch stat?
Why would a switch statement use a name?
Because it has that name that it has to, do all.
Or what
comparisons with.
parse tree node would that be? Name expression. So at some point, a name expression will get visited, and we'll have to look it up there.
So we have to differentiate between stuff that uses name expression and actual name.
Well, nothing ever uses a name, because whatever goes there is an expression if you look in the grammar. But you're absolutely right, yes, we do. Because if you have some place where you have, oh, good example, look in the grammar on the invocation. What type is the name of the method? I bet you that's not a name expression. That's probably just a name, if I'm not mistaken. Invocation is over under the expression somewhere. What? The one without the invocation? Yeah, method invocation. So page 18. It says, can either be name, it can be primary.name, super.name, or name.name. Right? So those are names. So that means that the name of the method we're invoking is a name, not a name expression. That's why we have to deal with it over there. Look at field decal. Sorry, field ref.
So I see field access, postfix.
Yeah, field
expression.
access. Field access.
Field access uses name.
Yes. So it's primary.name, super.name, or name.name, right?
Mm-hmm.
I think at the bottom one, name.name is useless, but that's fine. So that name will also have to be looked up. So field ref check field table for field of the same name. Again, if target is simple enough. That could also be rather complicated. Okay. Another thing that uses a name is a class type. If you look class type up, that's just a name as well. What should I do if I hit a class type? Well, I want to see that that class that it refers to exists. How do I do that? Check the class table. Right? It's global, so that's easy to do. Okay, we have a block, we have class type, we have field ref. Let me just try to do a count here. Oops. So